All right. Wait. Let me make sure my screen flash. Everybody has the seminar notes, right? If you don't have it, you can download the PDF file first. Then because normally when you register to the seminar, we will send you the notes. Okay. All right. Okay. Do you have this? Suppose you do, right? Over here. This is the one. Okay. For your seminar notes, it will be actually more. Because if you download the PDF file, right, it will be only the front part, which is the one we are doing today. But inside the seminar notes, right, I actually put more in because you guys having midterm, so I was figured that might as well prepare a bit more. So that's why the seminar notes, the whole thing inside, you have seminar questions, and also at the back, you have the midterm questions. Okay? Now, short notes in front, these are the short notes that we normally use it for. These are the short notes where we normally use. I mean, this one you will notice one thing, like the note is not exactly. Cannot hear? No sound. Got sound what? You sure or not? Can you hear me now? The mic is working. I think it's your problem already. You need to join and rejoin again. The rest of you, everybody, can you hear me now? I think so. The sound is working. I checked the mic, totally fine. Right. I guess so. Can hear, right? Okay. All right. So over here, this is the one. You will notice I put in a lot of short notes one because short notes for one reason. These are the topic that you normally screw up in the exam. Yes. But I didn't put the whole thing in, of course. Every chapter put inside too much. Okay. So I only select a few topic that normally you have it. Now, Form 4, Chapter 3 is one thing. If you're Form 4 for finals, right, they didn't ask about Chapter 3, as in essay, right, then there will be one part you probably want to pay attention to, which is this one here. Because if you say Chapter 3 will come out essay, there's only one subtopic anyway, the satellite. Okay. Then after that, you also have this one, wave. People normally confuse with the interference part. And then finally, you have this one. After wave, of course, we got light. Lenses are also typical thing that come out in exam. And then Form 5, Chapter 1, Form 5, Chapter 2, everything inside. So the plan today is to do more Chapter 2 actually, because for one reason, midterm, I guess, no matter what school you go to, right, Chapter 2 should come on. Right, because some of you told me that Chapter 3 is not coming out. Some of you say that, oh, my exam until 3.1 only. Well, if it's only until 3.1, then practically means little bit only. So this is why I want to do more important chapters, as in the one that come out more often. Okay. Pressure, yes, well known because for one reason. The back part of pressure, right, you got all the principle thing. Pascal principle, Archimedes principle, Bernoulli principle, all this principle thing. So this is why, right, over here, the seminar notes questions, I focus on the Form 5, Chapter 1 and Chapter 2, right? In a normal class, I think we kind of gone through the question as well. We did revision together also, all the trigonometry thing, sine, cos, tangent, all this thing, right? I didn't do spring is one thing. So later, if I have time, I want to do this, and then we will see how it progresses first. But most importantly, right, today, we focus on this one here, okay? Now, let's start with Chapter 2, question number 6. You look at page 21. Okay, look at page 21 over here. 21. Everybody, whoever just got in, page 21. Okay. Now, do you remember your Chapter 2 or not? I guess all of you learned Chapter 2 already, right? Because definitely Chapter 2 coming out, yes. Any one of you, your Chapter 2 not doing? Form 5, Chapter 2. I guess this is important for you. So, let's see what we have here. Now, Chapter 2, the focus is the back part. Because you have all the principal stuff, right? So over here, you can see diagram 7.1, you have a Cartesian diver in a plastic bottle. X are the holes that allow water to flow in and out of the Cartesian diver. Now, of course, you say, hey, I don't see this in textbook though. Well, this thing, the name sounded like, something very, very difficult. It's called Cartesian diver. I tell you what, it's just an instrument. It's a very simple instrument that demo how the Bernoulli principle works. Okay, how the Archimedes principle works. Speaking of this, when we have different kind of principle, right? You see, you got Pascal principle lah, Archimedes principle lah, and then Bernoulli, right? So you will ask like, hey, there's so many principles. How am I supposed to know which one, right? Well, one by one. First thing, Archimedes. How do you know we are doing Archimedes or not? Number one, you will normally see they put the things inside water. Now, is it a must we put water? No. It can be air as well. Because the proper answer, where do we get buoyant force? Whenever you are submerged in a fluid. Fluid means liquid or gas. Both liquid or gas also can. Yes, usually we do liquid, but now, example, hot air balloon. We are in air, what? The balloon is still floating, right? How come? Because the balloon is submerged in the air. You get what I mean, right? Yes, most of the time it's liquid, but air also possible. Okay? Now over here, you look at this diagram, right? I tell you how this thing works lah. You know why they leave hole here or not? You see, initially, right, this Cartesian diver, it's just a little toy lah, a small one, and then inside is empty one, like air, basically. So why they say I need two holes here? These are the hole that allows water, okay, allow water to flow in and out. So having the hole, the water go inside. If you say you don't put hole, right, then the water is not going to fill up here. How are you going to float? Am I right? So that's a simple trick. So for question A here, they say the Cartesian diver is floating in the water. Now, whenever you're doing Archimedes principle, one thing very important is what? Pay attention to this particular word. Look for this magic word. Because when they say floating, then your life very simple. Okay, your question will be a lot easier because one thing, whenever you see this keyword, right, floating, what does it mean? If you translate into the proper answers, right, floating actually means buoyant force, okay, and then weight. What's the relationship between them? Buoyant force will equals to the weight, okay, buoyant force equals to the weight. But one thing, guys, this one you cannot simply use one, Buoyant force, is it a must equals to the weight? Not necessarily. Can be more than, can be less than, right? Then, of course, some people say, hey, floating, isn't it buoyant force more than weight? Actually, no. Now, look, here, they label two forces already, right? Here you got weight, and then after that, you got this upward force. They just put F lah, but of course you know, right? What's this F? What was this upward force here? No. Okay, I don't understand why people always come in reaction force. To be honest, we don't use reaction force too often. So the trick here is what? Look, whenever you submerge into liquid, when you submerge into water, air, you get buoyant force. Correct. So this upward force, now they ask you, right? Name the force acting upward. There you go. Buoyant force. And then you are doing Archimedes principle. Now next thing, right? Here, let me ask you this. If your buoyant force is more than weight, do you know what happened or not? Upward force is bigger than downward force. You're supposed to see the object move upwards. Now, the word is not floating. The word we use, right, is called rising up. Okay? And then if you go down, right, then we use the word sink. So normally we got three terms to use. Rise, float, and then sink. Right? So if they say rise, means what? It means that you are going up. It means that your buoyant force is more than weight. If they say sink, means the weight more than buoyant force. So float, right, it's stationary one. Exactly. So whenever you see this word, floating means you are stationary, not moving. And that's why, of course, second question we can get to point, right? Relationship between force and weight, we got answer already, this one. Yeah. Now, they never ask why, but you can make a remark for yourself. Next time you can see for yourself. Why do we say they're equal? Only if they say floating. Now, I get it. Some people say, hey, but then, right, I read textbook, they've been telling me this forever, whether floating or not. Buoyant force equals to weight, right? Now, you have to be precise. Whose weight? What kind of weight, right? Now, normally, let's say we don't care, floating, sinking, whatever. You want to say buoyant force equals to weight, can. But then that one is actually supposed to be like this. Buoyant force equals to what? They equals to the weight of the fluid displaced. Okay, the weight of the water displaced. The weight of the air displaced. Displaced means the liquid that you push away, that you push out, right? So this one, yes, always can use. Weight of fluid displaced anytime, can use one. Not necessarily floating. But if you want to say floating, right, then this one will equals to the weight of the object. Okay, buoyant force is supposed to equals to the weight of the object. So there are differences there. Object means refer to this person, this Cartesian diver. If you say displaced, right, it's the water that you push away. Different, So this one, you can use it all the time. Whether floating, whether whatever, also can use. But then when we say floating, right, then you must say equals to the object. Very good? Now, next one. They tell you the Cartesian diver sink when the bottle is squeezed. Explain why sink. Now, first thing first, what did I say about this? Floating, it's equal. But if we say sink means what? The relationship, it will be buoyant force. Okay, the relationship would be buoyant force and then lesser than weight. Or you can say weight more than buoyant force, correct also. Weight more than buoyant force, Can also. Yeah. No, guys, I need you to respond more often now because I get the same person always, the same few person always telling me that no point, and I don't know whether you understand or not. That's the main point. So I need you to answer my questions lah. Huh? So that's the point. Okay. So here, if they say sink means buoyant force lesser than weight, we good. Then how come suddenly the buoyant force will drop? I tell you what, it's not the buoyant force dropping, it's the weight that increasing. Because look, equal is like this, buoyant force 100, weight 100. Now, it could be 80, 100. That one you can tell me buoyant force is lesser than weight. And can also be 100 and then 120, isn't it? So what is the thing that actually changing, right? It's actually W, not buoyant force. Why? Now, when you squeeze the bottle, actually, what means by squeezed? Squeeze means you are pressing it, am I right? And when we say pressing it, meaning what? You apply something called pressure. So squeezing means you're applying pressure. And next thing, what happened? When you apply pressure, remember the Cartesian got hole, right? So when you squeeze, what happened? All the water got no place to go, they will start going into the Cartesian diver. So when you squeeze it, water starts to flow in. So this thing will start to fill up with water. Get it? Before that was air. Now you put water in. What happened? Do you have any change in buoyant force or not? No, you won't. Because why? Okay. Can you tell me what's the formula for buoyant force? Formula, the typical calculation formula, buoyant force is V rho G. So the only thing that affects your buoyant force, three things. I mean, to be exact, is two lah. Because to be honest, gravity don't really change what. Unless they say, oh, we go to the moon, we go to the Mars, then gravity changes. If not, right, most of the time you changes these two. Number one, rho means density, surrounding liquid, surrounding air. So this is water, then you put density for water. Okay? Then, no, this one inside water, nothing one. No. They put the Cartesian in the water, but the thing is, inside here, it's empty one. No, inside one is empty one. So what happened is, when this one density I say already, and the next thing is V. V means volume, right or not? Now, you need to be very accurate also. When I say V, everybody could tell me, oh, it's volume. But then to be exact, actually, what kind of volume is this? You got two answers. You can either say this is volume displaced, or another one that's more famous with volume submerged. What's the meaning of volume submerged? The part that is inside the water. So right now, is your entire Cartesian inside already. Exactly. So your volume won't change anymore. Now, unless the Cartesian is like this, half inside, half outside. Then they go deeper into the water, right? More volume. That's correct. But this one here, no. You are already fully inside. That means this is going to be constant. This is going to be constant as well. So that's why I said, in these situations, right, your buoyant force is not changing. What are you changing? Before that was air. Now you squeeze, water go inside, you start becoming heavier. So why this one? Is because your weight is increasing. Now, how do we answer this? Okay, one simple trick for exam, I tell you what. A lot of time, right, people say, hey, how? I'm not sure whether I've done or not. It's like writing karangan. It's like writing essay, You always want to think about your point first. Obviously, theory questions, more normally, you think about exam. The theory question, they give you how many marks? Normally, theory questions, how many marks they give you? Yes, usually explain questions like that. Explain this, explain why, explain what. It's always 4 marks, right? There you go. So 4 marks means 4 points. So you want to think about it. Hey, my answer enough or not? I got enough marks or not? Do I worth 4 marks or not? So first thing, you squeeze, meaning what? You force the water, go inside. Okay? Go inside. Second step, when the water goes inside, what happened? The weight will start increasing. So next thing, when you get weight more than buoyant force, and finally, means you got more downward force, right? The object will start to go down, they will start sinking. Okay? Now, of course, you say, then, can I make it come up? Can. You let go. The moment you let go, the pressure gone already. So the water will come up automatically because now, before that, you squeeze, you force the water in. So you are having the pressure outside bigger. But the moment you let go, right, this pressure gone. So supposingly all the water will come back out. That's why they prepare 2 holes. One is to go in, one is to come out. You get me, right? So that's a simple trick here. So first point, what do we say? When the bottle is squeezed, right, the pressure exerted on the bottle will force the water to flow into the Cartesian diver. Actually, you don't have to say Cartesian diver all the time. You can just say diver anyway, but not the real diver. This one is like a toy, basically made of rubber or plastic. So over here, like this. Now, second point, what happened when the water goes in? As the water flows in, what is the changes? Buoyant force don't decrease. You already inside water. No change in buoyant force. The thing that increases is what? The weight of the diver increases. Okay? Next thing, what happened? Thus, the weight of the diver will be greater than the buoyant force acting on the diver. Therefore, there will be a resultant downward force that pushes the diver down and sink. So here's your 4 marks. What you tell them, first thing is this one here. Bottle squeeze, your pressure exerted. Now, why do you want to squeeze the bottle? Because you force the water into the Cartesian diver. Okay, force the water flow into. And the next thing, when the water flows in, right, the weight will start to increase. And then, of course, weight getting more, meaning that it will be bigger than buoyant force. And then finally, you tell them there will be a resultant downward force, pushes the diver down and then sink. Oh, sorry, there's one more missing. Resultant downward force. Very good. Can? So how many marks do we get here? Talk about pressure. You get 1 mark. Weight increase, 1 mark. Weight more than buoyant force, 1 mark. And then resultant downward force, 1 mark. You see or not? So always, when we write any theory, think about it first. When you say, oh, I only got 2 points though, I only got 2 sentences. I squeeze the bottle, the Cartesian become heavier. 2 marks, oh? So put in more. Why do you squeeze water, then the diver become heavier? Because water go inside. And then diver become heavier means what? Lesser. Buoyant force as compared become lesser. So from there, you think about it and then you go on. Okay? Next one, state 1 applications that's similar to these situations. What kind of application in real life we have similar to this situation? What do you think? What do you think? Yep, submarine. Good. If you say submarine is not best answer yet. You know why? Such a big submarine. There will be one particular part of the submarine, right, that control this thing. So instead of telling me submarine, right, I want more accurate answers. The part should be what? Ballast tank. So you can write submarine ballast tank, or even you don't write submarine, don't matter what. You can just write ballast tank anyway. Okay. Most importantly, this thing. How it works? Ballast tank is like this. Okay. Imagine this one submarine from front view in front. So let's say submarine here, and then you here. So this is where you have the crew, all the people in the ship inside here. And then outside, right, you have like a one empty zone. I mean, of course, it's only for simple illustration purposes Is it real like that? No lah. But then, right, agak you can imagine, okay, no point for me to draw the whole structure, like this. So submarine, right, here they will have something called a ballast tank. It's like having a something to close it at first place. So let's say right now you are inside is empty, air. Okay, so your submarine may be halfway only, halfway inside water, halfway outside water. Okay, next thing what happened? You open up the submarine ballast tank. This one open. You are in the water, What's gonna happen? The water here will start to go inside, flow in, and then fill up this part. So what happened when you start having more and more water? Eventually you get heavier, right? Heavier means what? They will start sinking. So next moment you will notice your submarine will go from here and then all the way down, submerged. See? Once you go underwater already, then you close it, you'll be underwater. Yes, of course you say, then how do I come back up? Now, going down is never a problem, right? Like imagine you have a ship, you have a sampan. You can make the sampan go down to the water, right? You can make the ship go into the water, right? Just that they don't come back up, right? They just go down, that's it, right? Titanic, that's it, right? So, submarine ballast tank, one thing very special is what? It's not just only an empty place, This ballast tank inside has a compressor. Now, what it does, right, is that they produce very high pressure air. Air. So what happened when you want to come up? You need to get rid of the water inside, right? So inside here, you start producing high pressure air. All this air will start push the water out. When you squeeze them out, what happens next? Water go out. Inside will left only air. Inside only left air, right? So this thing will slowly come back up. But the whole process, you notice or not? What are you controlling? You are managing the weight of the submarine. You put water in for what? You want to make the submarine heavier. You take out the water, why? The weight will become lesser. But the whole process, any change in buoyant force or not? Buoyant force equals to V rho G. You are in the same water, you are in the same earth, and then you are in your volume of the submarine. It's fixed one, it's made of metal. They won't get bigger, smaller, right? So for submarine, what do we control? We always play around with the weight. You want the submarine go down, you make sure the weight increase by adding water. You want the submarine to come up, you make sure you decrease the weight by taking out the water. That's the simple trick we do it. Okay? Now, some of you, right, will tell me another applications one. Can you tell me what's another application that you learned before about Archimedes principle? Besides submarine, got one thing also. Not everything in water, what? Right, what else also gives you buoyant force and then they are not in water one? Hot air balloon, yes. But this answer here, I wouldn't recommend hot air balloon. I won't recommend hot air balloon. You know why or not? Because yes, hot air balloon uses, the applications it's Archimedes principle. But then, right, hot air balloon different. Do we put more weight in and out? No. Okay, you know how hot air balloon works or not? Like, let's say hot air balloon is right, you got a little balloon here, and then they tie rope here. After that, you got the basket down here so that people can stand here, right? Okay, now if I want the hot air balloon to go up, what should I do? If I want the hot air balloon to start going above, all the way up to the sky, what should I do? Well, some people say, turn on the fire, lor. Kind of true. Okay, then you think about it. When you turn on the burner, they start burning, right? What are they burning anyway? They are burning the surrounding air. It makes it hot. Hot air. Density high or low? Hot air less dense, right? Then this is where you stop. You're going to say, oh, I know. So the balloon become lighter. No. Look. Yes, hot air is lighter. But the thing is, actually, right, when you burn it, what happened? Lighter air, where they go? Low density air, where they go? Do they go up or do they go down? They're supposed to go up, right? So when you burn all this air, you're actually forcing all the air to go up here, and then go inside the balloon. And you know why is it called balloon? Think about it. When you blow air into the balloon, what happened to the balloon? You go like, the next thing what happened? The balloon go like, big, right? So here, as you keep having more air, what happened? Your balloon gets bigger and bigger and bigger, right? So can you tell me now what is changing? Am I really increasing and decreasing the weight? No, what is getting bigger? Volume, yes. So hot air balloon, right? We play with the volume. You want to go up, you increase the volume of the balloon. And next thing what happened? Buoyant force equals to V rho G. So when you make the balloon having a larger volume, next thing what happened? Correct. The buoyant force starts to increase. So you see how is that different, right? For submarine, we play with the weight. We control the weight more and less. And then for hot air balloon, we control the buoyant force. We make it bigger, smaller by changing the volume. So in this question scenario here, I wouldn't say you write hot air balloon is correct. They want similar to these situations. What is happening here for Cartesian diver? You control the weight. That one should be under submarine. If you say like, hey, what if I have like a Cartesian diver inside water and then I blow air inside, I pump the air and then make it bigger, then it will become like this. But we don't do that. We good? Can I move on some more? This one done already or not? Copying part. Okay, let me explain this. Answer is posted in GC already. Okay, and of course, if you are not my students, it's okay. Where you find this link, you can find answer there as well. Okay, I'll ask them post, don't worry about that. So if you miss copying, it's okay. Most importantly is how to understand. That the problem is always for understanding part. You get what I mean, right? So here's the thing. If you doesn't part to copy, it's okay. You can take a screenshot if you want to. If not, you can refer to the full answers. Same thing also. Okay, next one. Ministry of Defense is organizing competitions among engineering students to build a submarine. Right? You need to give suggestions to design the submarine. Okay, now you know that your essay got two types, right? You Form 4 exam surely done before. Right now, I think you should be clear with the format already. So normally essay we got two types. You got the decide essay, you got the design essay. Decide means they give you a table, choose. And then design means everything you have to write yourself. Okay, now of course that's why people hate design. Because you need to write everything yourself, right? But let me ask you a question. For design, right, how many points you're supposed to have? For design, right, how many points you're supposed to have? Essay, regardless design or decide, is always 10 marks one. But design, how many? How do I get these 10 marks here? For design, right, you're supposed to write 5 points, okay, and then multiply 2 because you got EC and Hurayan. So you put your point explanations together, they become 10. No need to write conclusion for this. You only write conclusion for decide. Like, tell them, therefore X is the best, therefore Y is the best. But this one is your design. You're not choosing. You tell me what's the answer, So, takkan the final sentence here, you say, can I say like, therefore my design is the best? Doesn't make sense, right? So design, right? No need to conclusion one. Just write point, enough already one. Okay. We done it so many times, you should know lah. If you really don't know, here's the reminder lor. Essay always leave your answer in table form. Do not do I do notice one. I do see people who actually gave me their midterm paper and then inside is all paragraph form. Now, here's one thing. Some teacher, they normally mark for you. Most of the time, they just mark you and then remind you, write table form. But some strict teacher, right, you know what happens if you write paragraph form? Like you write like an essay. First of all, secondly, therefore, besides that, all this like a one full paragraph like that. Words they will mark you 0. They don't bother reading one. Inside answer all correct, but 0 marks. That's why leave your answer in table form. Okay, so you need to design submarine. Always remember, answer questions. You need to see what they are asking for. What's the requirement? So now they want a design of a submarine that is safe, fast, and can travel deep under the water. So how do I have a submarine that's safe, fast, and travel deep under the water? Come, there you go. What is it? Simple lah. First thing, when we say submarine, what's the most important thing? Number one. What's the number one thing that you must have? Why you need to be safe? Submarine, why is it dangerous to go underwater? Pressure big, correct. Then, how do you solve this problem having pressure big? Type of material can? The wall, how? The wall of the submarine. Correct. You need, first thing, right? You need to make sure the wall of the submarine should be, yes, thicker. Thicker. Because why do you want the thicker wall? We don't build such a thick wall one because as we go deeper underwater, you need to withstand high pressure acting on the submarine. So as you go deeper, pressure go higher. So if your wall is not thick enough, right? What's the problem? Is that it's gonna crushed by the pressure. Material type also we can say, okay, the material of the submarine should be, okay, speaking of this, everybody listen. When we come to design essay, okay, whenever they ask for material, right, try to not tell them I want exactly one material. Now, not to say cannot, but listen, there's always a better material, you see. So, okay, how about this? You tell me, what are the material you want to tell me? What are the material you want to choose? Metal, of course, like what kind of metal? What type of metal that you want? I get a lot of stainless steels. Yes, normal stainless steel, alloy, right? Why do we do this? Okay, at the end of the day, why do you tell me like stainless steel and alloy and everything, all these things? Because this material, how? Exactly. So you mentioned the material because you see, all the things you gave me, there I can always have a better substitutions one. You understand, right? So instead of saying exactly what material, describe the property, describe the characteristics. Why do we choose steel? Why do we choose stainless steel? Because they are strong. Now, hard cannot, strong. Because under high pressure, right? Should be stronger. Okay, now got two answers I would say recommended lah. One, you can say strong. You know what's another thing? Your submarine is in water. No, not normal water, you're inside the sea. So what water we having? Salt, many salt. Now, seawater, what's the property? You learn in chemistry also, right? What happened when metal explodes to seawater? They rust faster. So the material of the submarine, okay, should have, how to write? High resistance to rusting. If you don't want to say high resistance to rusting, right, you can also say low rate of oxidations. You learn chemistry, right? You know what's the meaning of oxidations? For metal, for iron specifically, oxidation means rusting. So these two, you see, instead of saying what exactly material I want, I tell them the property. That's the difference there. Now, these two, I will suggest you write one enough because both is talking about submarine. You are repeating answers, right? Not to say cannot, because the thing is, these 2 points is not related. Strong and rusting, no relationship. But then you need to always have like different variety of answers. Now, of course, you ask, can I write more answers or not in exam, in SPM? In SPM, yes, you can put 6 points, you can put 7 points, it's okay one. But don't spam because when the more I say can, right, then you know what happened or not? Then you start telling me, then can I put 10? No not to this extent. So can write more actually. Like, you say, can I write both inside? Actually, you could. But the reasoning different. So you can't write together. You cannot give me one answers and say the submarine should be stronger and then does not rust easily. No, you want to separate them. Stronger for one reason. And then why high resistant to rusting? Another reason. Okay. So why do you want the material stronger? To withstand the increasing pressure when the submarine submerged to a deeper depth. Okay, if you're gonna say stronger lah, this one. Next thing you will ask me, hey, the answer here, right, kind of similar to first one though. Can I do that? Now in SPM, actually you can repeat answer twice. The third time they manage. So actually you can say, can I say like same answer, similar answer? Yes, you could, but maximum do it twice. The third time they manage. Now, so if you don't want this, it's okay. Talk about other things beside the pressure. Nah. You know why you want high resistance to rusting, right? Because you are in the water, man. So you can say that. What happened? So that the submarine does not rust easily when submerged, or you can say exposed in the sea water. Okay, so two answer, right? Either one, because the reasoning different. You say stronger because you want to withstand high pressure. You say you want to prevent rusting because they won't rust easily. Very good. Now one more. What else beside these 3 points? What can we say? Shape, good, because you want to travel fast, So what's the shape of the submarine? Should be shape of the submarine. Should be what shape? No. It has to be very specific terms one. You cannot tell me like, should be pointy, should be sharp, no good. Correct. Answer, you write streamline. Okay, I get this. Listen, don't copy. Look here. I get this. Some people tell me aerodynamic, right? Okay, here's one thing. What's the difference between streamline and aerodynamic? No difference. Same one. Same. No difference. Same one. But then, normally in exam, I'll recommend this. I strongly recommend this. If you want to reduce air frictions, air resistance, then you call it aerodynamic. If you want to say water frictions, water resistance, right, then we call it streamline. Yes, your teacher prefer this way. Because you see the word aerodynamic. What's the meaning of the word aero? Aero means air, right? So let's say now we are not looking at submarine. Maybe we're looking for like sports car, train, airplane. You want the sports car to go faster. You want the train to go faster. Bullet train, right? That one you say the shape should be aerodynamic because you got lesser air frictions. And then right now we're talking about ship, submarine. Then we call it streamline. And the reason is to reduce water resistance acting on the submarine. Okay? Or you can say water friction. Water resistant, water friction, same. Up to you. Water resistant, water frictions. Okay, but I'll always prefer this streamline rather than aerodynamic. Unless they ask airplane. Then you tell me the shape of the airplane should be aerodynamic because you want to reduce air frictions. So water resistance, streamline, air resistance, aerodynamic. All good. Aerofoil later. Some more? What else? What else can say? Got so many, right? Okay. You need to travel deep underwater for a long period of time, Submarine, normally they go underwater, they stay under. They don't just come up, go down, come up, go down, come up, go down. Because submarine is like, you want to stay hidden, right? You want to go to your enemy's place and then you shoot them, right? You don't want them to detect you, so you cannot just move like that. So what do you need? No, not size. Like your submarine will be underwater for a very long time. And then what's the problem when you're underwater for a very long time? Yes, you need oxygen. If not, how? Everybody inside die, what? So you can say what? You're supposed to equip with oxygen tanks. More oxygen tanks. What are these oxygen tanks for? To provide air to the submarine crew. Provide oxygen also can, air also can. Yep, some of you did mention, I think. Got one thing you forgot to mention actually. The most important thing about submarine is to be able to go in and out of the water. What do you need? What do you need to make the submarine, to ensure the submarine can go up and down? What's that? Correct. That one will be ballast tank. Equipped with ballast tank that has larger size. Larger volume also can, larger size also can. What is the function for ballast tank? Control flotation is not wrong, but you want to make it simple, you can say what? To pump in water and allow the submarine to submerge faster. Why do you want? Okay, here's one thing. Having ballast tank will actually make this, it will definitely can go underwater one. Okay, but then right, You notice my point, I say what or not? Have a ballast tank that has bigger volume. So why do you want bigger volume? Because when you have bigger volume, you can put more water into you become more heavy, that's why you can go down faster, so much faster. To pump in water and allow submarine to submerge faster. Can I say control weight of submarine? No, just say this will do. Submerge and decrease. Got one thing also. We prepare more lah, because you never know what, right or not? And then actually, yes, you can write 6 points, 7 points, just to be very safe lah. Got one thing actually very important you forgot to mention is what? How do you power up the submarine? How do you, because submarine don't move itself, what, right? And then you cannot tell me, oh, we hire people in the submarine and then we row the boat like that. No lah. What are the things? What's your energy source that power up your engine? What's the energy source that power up your engine? Okay, when we say energy source, what is the thing that we normally use to produce engine? But what is the material? What's the things that we use to produce we supply to engine. Okay, like say for car, you pump petrol, right? But then the thing is, for submarine, can we put petrol in? Fossil fuel, natural gases. Your petroleum, your fossil fuel, it needs to be combust, right? Think about it. What do you need for combustions? You need air, correct. You need oxygen. You got not enough oxygen to supply your crew already. You still want to use it to burn the fire. And then you know what's another problem about burning fossil fuel? Whether natural gases, whether petroleum. After burning, what are you going to produce? You will produce gas, all right? Carbon monoxide and everything. Where are they supposed to go? You cannot trap them inside. Everybody inside will die, right? They say, oh, we release outside, just all the way outside. Then, okay, pollution is not out of questions. I say, oh, then is it going to pollute the sea? Yes, that's one thing. But most important is what, when you release the gas outside, what happens? Yeah, you will be bubbling, right or not? Like imagine you move in front and the back of you, right, bubble, because you are releasing all the carbon monoxide, what? Right? Then everybody know where are you. Then you call yourself a submarine. Your enemy know exactly where to shoot, So petroleum cannot. Fossil fuel cannot. What other ways? Think about it. What are the other way of generating energy? Diesel it's the same one. Any fossil fuel you burn, right, confirm got oxygen. Carbon monoxide. Nuclear energy, correct. Solar, your head, hello, you're under the sea, where got sun? So put solar panel, cannot be, right? So you can say nuclear powered engine. You know why is it good to use nuclear power engine? Produces a large amount of energy to power the submarine. Okay, number one, nuclear energy is actually very good source of energy. Do you know why or not? First, nuclear, right, produce a lot of energy. When we say a lot, it's like crazy lot. Simple comparisons are, it's like if I got 1 kg of petroleum versus 1 kg of uranium. Uranium is people use for generating nuclear energy. The uranium will produce a lot more energy compared to petroleum. Second thing, nuclear don't need to release, and there's no burning. They just reaction and then release it. So they don't release any carbon dioxide, carbon monoxide, whatever thing. So it's cleaner. Actually, a lot of people don't realize, most of the time when we say nuclear power plant, you start thinking that, very dangerous, very dangerous. You look at other country, right? Now, Ukraine has this country, has this place called Chernobyl, right? Well known for the nuclear power plant meltdown, right? It exploded and then the whole area cannot use, right? That one is if there's accidents. And all these, right, all the incident that you heard before, they're usually caused by human errors one. Like, okay, the Ukraine one most famous, the Chernobyl one. What's the problem, right? Is that they could have contained it. Yes, they could have prevented one. But the problem is because the people inside, the staff inside, the worker inside, they try to hide it. Means they don't want to tell. They thought like, okay, I can settle one. And then they start realizing they cannot settle. Next thing what happened? The power plant meltdown. So normally, when your power plant has problems, right, nuclear power plant, if we actually solve it immediately. We actually like try to save it immediately. Can be done all the time. Most of the time can not a big issue. The problem is they don't want to tell. They try to like, oh, what if I report to the company now? I'm losing my job because they think I cause it to fail, right? That's the main problem. Nuclear actually is a very good source of energy because why? Number one, a lot. They produce a lot of energy. Second, they are relatively green. Like burning of fossil fuel, what do you produce? Greenhouse gases. Nuclear won't. They use one thing only, water. They produce one thing only, steam. No carbon monoxide, no carbon whatever thing. Get what I mean, right? So nuclear is always the best. And somehow you need to go underwater. So you need something that can produce a lot of energy to last you underwater for a long time. Electricity cannot, you know why? You say, just like electric car, we charge it. Now, any one of you, your house has an electric car. What was the biggest problem about electric car? They are not as much as you think it is, right? Normally, they show like, oh, you still can drive for 500 km, then suddenly it will drop down until 350 km. That's the thing. So electricity not practical because you have to charge it, and then they will finish quite fast anyway. So nuclear is the best. Okay. All right. Can I move on? Next one. All right. Setup 8.1 shows the basic working principle of a hydrometer. The depth is which the test tube sink depends on the buoyant force acting on it. Okay, first, this one is not called a hydrometer. Okay, this is not called a hydrometer. This one is actually a simple demo only. We don't use a test tube and then say this hydrometer. Hydrometer actually look like this one. I can show you. Okay, hydrometer, right? Next time you in yes exam ask one, it will be like a tube, a thin one, a small one, and then they go down already. They suddenly become big like this. Bigger like this, and then toop, like this. Now the proper hydrometer should look a bit like this, and then inside here we put a lot of lead shots. You know what lead shots are? Basically like small stones that are made of lead. And then you know why they like putting lead here? Because lead is very heavy. So when you put here, what happened? The bottom is heavy, the top part is lightweight, right? They will stay upright in the water. Hydrometer looks like this. Yes. How it works? Very simple one. You throw inside the liquid that you want to measure. Then they will start to submerge until the density level of the liquid, they stop. Then you take the reading here. If they say 500, meaning what? The density of the liquid is 500. So if you put something with even lower density, they will submerge more all the way. Because lesser density meaning you got lower buoyant force. Then you need to submerge more. Lesser buoyant force, right? You submerge more. So here's one thing. Thermometer got one thing very interesting is what? The big number is at the bottom one. The small number is on top one. It will be the value of your thermometer. Normally thermometer 0 here, 100 here, right? Right? But then for hydrometer is no 0 1, 100 here, 1000 here. Because the more density you have, the more buoyant force you produce, they will push it up more. They will float more, they will submerge less. And then you got lower density means lesser buoyant force, they will submerge more. You get me, right? A simple mathematics this one. You see, how do you calculate buoyant force again? Formula, buoyant force equals to V rho G. Okay? So what happens is like this. You assume buoyant force to be constants. Don't change. Because buoyant force is only to support the weight of the thing. Your weight is fixed one. So think about it. When density changes, you know what they affect or not? They affect this one. Gravity fixed, right or not? So if I put this thing into something that has low density, simple mathematics, everybody, if this one drop, what happened to the value for V? What happened to your volume submerged, volume displaced? What happened to this V? Is it supposed to increase or decrease? Correct. They're supposed to go up and increase because your buoyant force fixed. Why fixed? You only need the same amount of buoyant force to support the weight of the object or weight of the whole thing. Your weight don't change, right? So over here, you submerge more to have the same buoyant force. It's like compensate idea like this. The buoyant force is 10. So if your density is 1, then volume submerged has to be 10. But if your density is like, let's say density is 1, it's 10, then this one will be 1. 1 times 10 equals to 10. Understand what I mean, right? That's a simple trick. Okay. Next one, A. Name the physics principle associated with hydrometer. I think we answered already, right? Hydrometer means under what? Correct. Archimedes. How to spell? Archimedes. And then only you apostrophe S. No. There's no S, my bad. Like that. Archimedes and then comma. The comma at the back. Because most of the time, this comma we put here. But the problem is because Archimedes, the letter S is part of his name. That's why we put the comma at the back. And this one is your English actually. You cannot double S one. Yeah, you should know this. So Archimedes principle. Okay. Alright, this page got problem or not? If not, I move on. Next one. State the relationship between buoyant force and weight of the test tube. Come, what's the answer? Buoyant force. Sorry. Buoyant force. And then weight. What do you put in between? What do you put in between? You put an equal sign, correct? Okay, but then some of you will be in doubt, or you say, hey, can simply put buoyant force equals to weight one? Is it always a must buoyant force equals to weight? No. This one, yes. But what did I say just now? Under what conditions, then only you can tell me buoyant force equals to weight of the test tubes. Yes, when they are floating, Okay, then we look up, Okay, then we look up to the questions, right? The question actually says this test tube is floating. You read this part, any word that you can find, magic word, floating, floats. No, right? Then how? Say, hey, this one, never say also, can assume one. Okay, this one a bit hidden, a bit subtle. Yes, it is floating, but without telling you floating. But how do you know it's actually floating? You look at it, got one thing, anyone can tell me, right? How do I know this thing is actually floating? It's a very simple reason. It's because of this. Do you realize they actually tell you the test tube is like 4 cm underwater, 4 cm inside water? Now, how do they know it's 4 cm? I mean, how would you know it's 4 cm? Then you tell me, oh, I measure it exactly. Now, if you can measure exactly here 4 cm, meaning what happened to this thing? Is it moving? Okay, imagine right now you have the test tube, but the test tube is like moving up and down. Okay, imagine test tube this one but imagine now the test tube doing this, up and down, up and down. Could you tell me exactly how many percent submerged, how many cm inside? Because they are moving up and down, all right. So under what conditions you could actually measure it? Yes. So because of this, next time if they do tell you it can submerge 5 cm cube, 10 cm, whatever, they tell you specifically how much inside, how much outside. It means that they are stagnant there, so I can put my ruler over and take measurement. You understand, right? So this one never say floating, but yes, it is floating because they give you number that underwater. Yeah. Next one, calculate buoyant force on the test tube, and then the mass of the test tube is given. The mass of the test tube is actually 0.05 kg. Okay, first thing first, could you tell me the formula for buoyant force? Anyone could tell me what's the formula for buoyant? The basic one first. Supposingly buoyant force equals to B rho G, right? And then you ask for yourself, do I have these informations? Do I know the volume submerged? Did they say anything about how much is submerged? No, they didn't, because why? This one is not volume, that's height only. So you don't have this. How are you supposed to proceed? Never mind. Because why? Right now, we can say the buoyant force, how? Yes, for this scenario, for these situations, right? We can say this buoyant force, it's actually equals to the weight. That's why I say always look for the magic word float. Because the moment it floats, the buoyant force, you can calculate without using formula. Just calculate the weight of the object, got answer already. But again, only do this if they are floating. Weight, how to calculate? mg. So you understand now, right? They give you the mass of test tube, right? Because this one here, 0.05, and then g value would be 9.81. Everybody, calculator please. Can you calculate this for me? How much? 0.05 multiplied 9.81. Yes, you get 0.495 Newton. What's this? The weight of the test tube. What's this? The buoyant force acting on the test tube. How come? Because the buoyant force equals to the weight. Understand? Good, So, a lot easy, right? It only become easy if it's floating. If they never say floating, okay, and they didn't say the 4 cm whatever thing, they ask you to calculate, then you have to do V rho G. If not floating, can only use V rho G. Yes. If they never say floating, then you have to calculate using this formula. Volume submerged, density of the liquid, and then gravity. That's why a lot more troublesome, right? So why I say look for this word, because once you confirm they are floating, then your calculation becomes easy. So if it's not floating, you can only do this. And then the weight of fluid is fixed. Next one, same test tube, immersed in a beaker of petrol, predict the length of the test tube submerged. Explain the answer. Now, before that, this is water. Now we take it away. I put petrol inside. What do you expect to see? This test tube will go inside more or come up? Go in more or come up? Okay. Then first thing you think about it. What is the difference between water and petrol? Flammable your head lah. Hello. This is about buoyant force. Flammable, that one chemistry, what? Yes, density changes, right? Then density how? Petroleum is oil lah. What do you think? Petrol, density high or low? Less dense, good. Less dense. Petrol less dense, what? That's why, you know, they told you, right? Let's say, if you see like petrol on fire, you're not supposed to put it out with water, you know. Some people say, hey, fire, water. Always, fire means water, right? Cannot. Because when you pour water, the petrol will float up. You're not going to stop them from burning one. That's why, okay, do you know the fire extinguisher? Got different type. Some says carbon dioxide one. And then some says ABC powder one. Right? So why they use this rather than water? Because powder form absorbs the petroleum and then they cut off the fire. Okay? Anyway, back to this. So density drop. Next thing. Density drop means what? It leads to what? One by one relate. Density drop means what happened to your buoyant force? Okay, a lot of people say buoyant force drop, right? Actually, no. Listen. Density drop, your buoyant force same. How come? Now, again, you want to make sure the test tube floating in the water, yes? And then again, in order to be floating, meaning what? Buoyant force needs to equals to the weight. Why? Because you need to generate the same weight, same buoyant force to support the weight. Understand what I mean? Same buoyant force, same weight, right? That's why the answer, actually, you look at this question this way. A lot of people can now buoyant force, because people straightforward thinking is that they will tell me the density drop, their buoyant force lesser. But actually here, you know what's the thing or not? Buoyant force equals to V rho G. Okay, your buoyant force is fixed one. Because no matter what you use, I don't care, it's a water, it's a petroleum, it's a whatever thing. I want the test tube to float means I need to generate same buoyant force to support the same weight. You replace the liquid inside, are you going to affect the weight of the object? No, right? So same weight means same buoyant force. Now, here, gravity constants, buoyant force constants, density drop. What happened to this V? Supposed to increase or decrease? Simple mathematics. Correct, good. The volume will increase. Because now, if you have the same volume submerged, lesser density means lesser buoyant force. Your buoyant force drop, right? But okay, let's say my weight is 10. Okay, 10. So when you reduce density, your buoyant force become 8. Now, not enough, right? I need to make up the losses, right? I want more buoyant force so that I get 10 and 10, right? That's why you submerge more to compensate. Because this one dropping, then you tabale the volume submerge more to compensate the loss in the density. Get it? So answer is, if you use petroleum, right, what do you expect to see? The test tube, rest tube. The test tube will submerged, deeper into the water. Oh, sorry, no need to say this, my bad. They say predict the length. Just say the length of the test tube submerged in the into the liquid will increase. Why? Explain the answer. How come it's submerged more? First thing, tell them what? Petrol has a lower density than compared to water. Okay. Then the test tube will submerged more, or you can say submerge more deeper also can, into the liquid in order to produce buoyant force that supports the weight of the test tube. Okay. So most importantly, you want to tell this length of the test tube increased. Why? Because petrol lower density, so you submerge more to support the weight, the same weight anyway. They won't change. Understand? Clear? Okay. Some more, next one. Diagram 8.2 shows a model of sampan P or Q. This one no need. I don't know why they put a sampan P or Q there. There's only one sampan. Okay? Used to ferry passenger. The sampan will sink if the water level exceeds line WR. WR is over here. Basically, they're telling you this is the maximum limit. Anything over, if the water level go higher than this line, like here, then the boat will sink all the way. Because if you get too high, what's the problem? The water will go inside. Then they start sinking. So they give you informations where they tell you the mass of the sampan is 100 kg. And then the average surface area, means area anyway, is 2 meters square. They want you to calculate the maximum mass of the passenger that can be ferried without exceeding line WR. Now, how do we do this? So the requirement is you cannot go more than WR. Meaning maximum thing you could do is the boat submerged until this level only. So if the boat only submerged until this level, meaning what? The buoyant force you generate is only this much. Okay, this is the amount that you generate. Okay, so how many person can I put inside? Well, the thing that you want to achieve is what? The buoyant force equals to the weight of the boat and sampan. I mean the customer. Now you can separate, calculate. Never mind. I show you. Don't copy anything first. Look. First, let's calculate the buoyant force. Because they say, right, this is your maximum line. So I want to know, right, what's the maximum buoyant force I have? Then I will know what's the weight I have, because that's if I have maximum buoyant force 1,000, means I can support 1,000. That's it. Right or not? If you got 1,002, your boat will sink. Agree? How do we calculate buoyant force? V rho G, good. What does the letter V stands for again? No, when I ask like that, I want a more complete answers. I want a more precise answers. What does the letter V stand for? Volume, no good. To be exact, what's that? Volume submerged. Meaning what? The blue color part. But then, let me ask you. Here, they tell you, this is the whole thing, 0.5 meter. And then this part is 0.12. That being said, right, what's the length here? 0.5, 0.12. Then obviously, this is what we have, right? 0.38. But I want to ask one thing. Can I substitute this one inside here? Can I just take the 0.38 meter, put volume? Because exactly, this is meter, not volume, right? Then how? You look and see. What else given? You know why they give you an area or not? Reason very simple, guys. How do you calculate volume? Now, any shape. This one mathematics doesn't matter what shape. Okay, let's talk about basic. Imagine you have a cube. You have a cuboid. How do you calculate volume of that cuboid? You take the length, okay, times the width, right? Because when you take length times width, what happens? You get the basic area already, like this, right? And then after it times height, you get the whole thing, volume. Whatever shape, same thing one. Now let's say cylinder. Pi r square means what? The base area, right? Times height. Then you get volume. Right. Of course, we are not doing maths here. Relax. This is why, you see, they actually give you the area already. What? You don't have to calculate area again. But I want you to understand one thing. You cannot take this 0.38 straight away because they are not volume. Volume are calculated this way. How do you calculate volume? You take area multiplied by h. Okay? The area multiplied height gives you volume. Get it? So over here, what's the maximum volume I can put inside? The line WR. So it's the 0.38 and then multiply by the area 2 meters square. Density given also, right? Density is 1,000 and then G value would be 9.81. Okay, calculator please. Let me calculate this. No. Don't. Later I offer you another faster way. This is only the basic way to let you understand. Now, well, of course, if you like it, you say, can I write this way in exam because I understand this way? Yes, but lengthier. Okay, now first thing here, you found out this amount, right? 74 5.6 Newton, agree? Now, what does it mean by this? This would be the so-called maximum buoyant force. Okay, because the maximum you can go to is this line, what? You can't go any higher. That means the buoyant force maximum at best, you only generate this amount. That means you only got this amount of buoyant force to support the weight of the passenger. Yes. So what you do, very simple. Do you remember how to calculate? The question want to calculate mass, right? Now, do you recall the formula for W equals mg? Weight, right? So the weight I put 7455.6. You know why? Yes, because this is the amount of buoyant force I have. But then this is the one typical thing that people lose mark. You know why? Equals to mass multiply 9.81. Could you calculate how much is it? 7455.6 divided by 9.81. How much? 760 kg. Did you find this? But is this your answer? You see, I ask like that, you know lah. This one is the maximum total mass that your boat can withstand before it sink. But why I said this is not answer yet? Because they only want the mass for the passenger. Of course, you ask, is there any difference between this? Yes, there is one thing. Correct. The sampan itself, right, already 100 kg. Yeah, so can I take this or not? No. The maximum one, you need to minus off the sampan. Then you get 660. This is the answer. Maximum, we can take 660 passenger. I mean, in terms of kg lah. Okay. But do you feel like this working a bit like lengthy? Now, why I do this? Because easier for you to understand. You can understand what's happening one by one, all right? First thing, I find out the maximum buoyant force I can generate. When my water level here, how much buoyant force am I generating? 7,455.6. That means that I can support maximum 755.6. So this is why I divide 9.81, I get this one here. This is the maximum mass. But here's the problem. When we say weight, beside the person inside, you definitely have to include the boat, the ship, the sampan mass, right? So we minus off 100 from the sampan mass, and then the leftover would be the passenger mass. Now, if you don't want this way, I give you another way. Of course, there's always another way. I mean, not easier lah, shorter working law. Okay, if you prefer this way, if you tell me that, hey, this one I can understand, I know what's happening, I like this way, then by all means, go ahead. If of course you ask, if I write like this, do I get marks in SPM? Yes, 100%. Physics always understand this. There's no absolute answers, you see. Is it a must do this? No. You get answer, you are correct. I don't care how you do it on actually. But in fact, you know what can we do or not? We can actually equate the formula together. What you think about it? The buoyant force you calculated end up went to here, which is the weight, right? So we start off by saying this. The buoyant force, I need to have maximum buoyant force to support the maximum weight. How do you calculate buoyant force? Formula again, V rho G. How do you calculate weight? W equals what? Mg. You know why we equate them together? Because right now, we can cut off the small g. You don't even need to multiply 9.81 and then divide 9.81. No need. They already cut off. So finally, you get what? This V is submerged. Same thing, the volume submerged is 0.76. Okay? And then after that, the density is 1,000 because they give it to you. Equals to the mass of the boat. So finally, what you get? You get answer straight away, right? Now, you want to make it more, you can say mass of the sampan plus the mass of the passenger. I put P lah, mass of passenger. So the mass of the passenger is supposed to equals to 760 minus sampan 100, and I get 660 also. But you notice my working is a lot shorter, right? Because your one like literally have to do 3 steps. Find out buoyant force, find out what's the total mass for everything, and then minus off to get the passenger mass. But with this way, right, I can go faster. But of course, I don't want to force you using this method because why? Some of you say, oh, this one, an exam, I cannot thought of it. It's okay, man. You get answer, you are correct. So if you like this way, step by step, clearly show, do this. If you want to combine the formula together faster, you get answer, you are correct. Up to you. Okay? Can I move on some more? Done, calculations? Let me know. Can I move on? Because I scared, when I move on already, then too fast, you say, hey, I haven't finished copying yet, then I let you be. This one here, volume of the boat, volume submerged. This one, same. Because it's V rho G what. So why is it important to write down formulas? Because you will know what are you doing. Sometimes you write, hey, where does the number come from? Right now you can tell. Okay, move on. Next one, question 7. Next page, 7. Diagram 3.1 shows 2 balloons suspended by threads at the distance of 12 cm. When the air is blown between the 2 balloons, what happened? Okay, this one, what kind of principle we're dealing with? Archimedes, Bernoulli, Pascal, what do you do? Okay, this is your key idea. Air is blown. Okay, what did I say just now? If you see something submerged in the water, submerged in the liquid, in the air, then it's buoyant force, right? But did I put this anywhere? Of course, some people see the word balloon. Oh, I know, Archimedes. Is it floating? It's suspended by threads, hang there one. Then how do I know this is Bernoulli? Bernoulli is among 3, right? Among 3, Pascal, Bernoulli, Archimedes. Bernoulli is the one that you will start seeing liquid flow, air flow, gas flow. Okay? Now, remember, whether Archimedes, whether Pascal, whether Bernoulli, right? We like using this word a lot. Fluid. You know what it means by the word fluid or not? Liquid or gas. So not just only liquid, can be gas as well. Liquid or gas. That's why just now I say, right, buoyant force, is it a must I put inside water? No. I put inside fluid. Water also can, gas also can. Same thing here. Bernoulli also works for water and also gas. So you see here, air blow, right? So air blow means what? If you blow between here, what's happening to this zone? Blow means what? Correct. This part, the velocity will be high. And then next thing what happens? If the velocity increases, think about Bernoulli. Velocity up, meaning your pressure will be lower, right? Then outside here, what happened? Outside here, as compared, you have bigger pressure, right? Now, I write like this, does not mean I got bigger, my pressure increase. Outside, normal, surrounding typical pressure. Okay, surrounding typical pressure is the main thing here. You increase the speed, that's why it causes the pressure to drop. So here, abnormal. This one is just normal, surrounding pressure, surrounding atmospheric pressure. Understand what I mean, right? That's a simple trick here. Speaking of Bernoulli, do you recall definitions? What's the Bernoulli concept? Velocity up, pressure down. Velocity down, pressure up. And one thing, guys, no, you cannot tell me they are inversely proportional. Because a lot of people see this one, up and down, oh, inversely proportional. Now, I say this again, you can only say something directly proportional, inversely proportional, if they give you a graph. If you have a formulas. For Bernoulli principle, you got neither or both one. You got no graph, you got no formulas. How do you know? Exactly. So don't use inversely proportional. Just typical one, velocity increase, pressure drop, that's it. But one thing I also want to emphasize, where a lot of people actually, you tend to forget a lot. Not to say forget, you just forgot to write it down. Before you want to say any of this, velocity increases, causes pressure to decrease, velocity decreases, causes pressure to increase, right? One thing first, you want Bernoulli principle to work. The airflow must be how? Even in the definitions, it always starts from this sentence one. In a gas, steady flow of fluid. If you blow the air one time only, like just, that's it, one time, you're not going to get any buoyant force one. Buoyant force, Bernoulli principle. Bernoulli principle is like, you need the airflow non-stop. Like airplane, do your plane straight away take off, move forward, up. You realize they need a very long runway to let air flow non-stop, right? That is the meaning of steady flow of fluid. Meaning you want the liquid, you want the gas, you want the whatever fluid, steady flow non-stop. Then only this happens. Get it? Okay, good. Now, Bernoulli, I can teach you one thing. Because to be honest, Bernoulli is among 3, perhaps this one easiest. Pascal, Archimedes, Bernoulli. Because why? Bernoulli got no formulas one. Okay, I cannot say no calculations. No formulas. Pascal got Pascal formula, Archimedes got Archimedes formula. Like Bernoulli, most of the questions are theory. Got calculation later I show you, but we don't have formulas for Bernoulli. Okay, Now then you say, hey, then am I supposed to memorize all the theory, whatever? Now here's the trick here. Bernoulli principle, okay? Bernoulli principle, the trick is there's a format one. Whatever questions, whatever scenario regarding Bernoulli, I give you a simple format. You always do it this way. Number one, mention this. Okay? You always mention steady flow first. However you want to start, steady flow of liquid, steady flow of air. Second thing, compare the velocity. You tell me, oh, here the velocity higher, that side lower, upper region faster, compare. After compare velocity, compare the pressure. If the velocity increases, pressure will drop. Velocity decreases, pressure will increase. Okay. Finally, why do you always want to have this different pressure? Pressure always push from high pressure to low pressure. Here, you see, this pressure outside big in the middle small, right? What happened? Pressure high, push to pressure low, pressure high, push to pressure low. Now, I say it this way in layman term, right? In exam, please don't say pressure high, push to low. I tell you what, the final point, what do you say? Pressure different, right? Then we say difference in pressure. They will create a force. Can be lift force, can be down force, can be whatever force. But this is how you answer for Bernoulli principle. Every time, right? 4 points, tell yourself, I want to talk about airflow steady, compare my velocity, compare pressure. When you got different pressure, you create force. Understand? Now, first thing, answer, I think you got it already, right? Air is blown between two balloons. What will happen? You blow here, the balloon will stick together, cannot. Because is it a must? They must touch each other. It depends on how fast you blow. Depends on how big the difference is. Maybe you just gently blow a bit like this, just that one no difference. What you want, like, okay, let's say you blow very fast and very strong, like that. Then high velocity, pressure drop very low. Then you will see the balloon close to each other. So they can just tell them the two balloons will be closer to each other. Okay, we'll move last, right? Two balloons will move closer to each other. Got it? Can I explain the answer? Now we go. How do we explain? When the air is blown in between, the air is blown between the two balloons, steadily. What happened? Try the point I teach you. First point, steady flow. Mentioned already, air flow through the balloon, between the two balloons steadily. Next thing, the velocity of the air in between the balloon, in between the two balloons will increase. Okay, someone? Increase already what? The pressure of the air in between, the pressure of the air in between the two balloons will increase or decrease? Decrease as the velocity of air increases. Finally, talk about velocity already, talk about pressure already. Finally says what? The difference in pressure will create a force to push the balloons towards each other. Now you look at my answers. Is it right I told you? Nah. Air flow through steadily. Talk about velocity. Talk about pressure. Pressure difference create force. Exam, this is where your marks come from. Okay? Airflow steadily, compare velocity, and then velocity high means your pressure will be lower. High pressure, low pressure, difference in pressure. Create a force pushing each other. Later we try one more, you get what I mean. Okay, next one, physics principle involved. I think we can answer already, right? This one should be quite easy. Bernoulli principle. Oh, spelling, by the way, guys. Bernoulli got double L one. Bernoulli got double L. Pay attention. Okay, the spelling. No, you spell wrong, they don't give marks one. No. They're not going to give you any marks. That's the problem. Okay. Next one, diagram 3.2 shows an aeroplane with a 25,000 Newton force. Lift force, flying at a constant height. What are the shape of the aeroplane's wing? Yes, come. What's the shape? Name. Now you tell me the shape should be aerofoil. Okay, people always ask one, hey, the aerofoil aerodynamic same? Of course, no lah. I said just now what? What's the function for aerodynamic? It's to reduce air frictions. But what's the function for aerofoil? Is to make sure the plane produce a lift force to make them fly. Okay, of course you feel, but the name sounded so similar though. Are they related? Kind of, but you can say related and not related. Okay, I'll show you how. The exam don't ask you draw, relax. Okay, first aerodynamic, right? It's a perfect symmetrical teardrop shape. Okay, it's a symmetrical teardrop. They look like this. Okay, teardrop. So you're supposed to have one more point here, and then I flip over like that. There you go. Now you will see they look symmetrical as in this way, like this. How about this? Looks like a teardrop or not? That's the meaning of aerodynamic. Both up and down, right? They are curvy one. Both up and down, they are curved. But then, right, if you want an aerofoil, what you do actually very simple. How they are related, see? I take aerodynamic, okay? Then we cut it into half. This will be aerofoil. Get it? So the difference aerodynamic versus aerofoil. Alright, these two. What's the difference? Aerodynamic, what's the functions of it? Aerodynamic is meant for you to reduce air frictions, air resistance. That one is the function for aerodynamic. Whereas for aerofoil, right, what's it for? This is to create lift force. Okay, to create lift force by using the difference in pressure. So there are two different things. Now, airplane is the best example. You know why or not? They have both. The body for the airplane, it's aerodynamic because you want to go faster. But the wings for the airplane is called aerofoil. Understand now? Okay, don't confuse this anymore. I get it. I get this question every single time. Every time students come and tell me, hey, teacher, I cannot differentiate aerodynamic, aerofoil. That's the thing, difference between them. Yeah? And you know how aerofoil works or not? Airplane go forward, the air will flow through them, right? Top and bottom. Again, air flow through the wings steadily. And next thing what we do, compare the velocity, right? Where do we get high speed for aerofoil? Where do you get higher velocity of airflow? Do you get it on top or bottom? Airflow up here, it's actually faster compared to airflow at the bottom. Okay, of course you ask, hey, why? Now, remember how I tell you how do we get this aerofoil? So this, it was like an aerodynamic and then half, right? So did you realize the top part of aerofoil here, they kind of look same as aerodynamic. Curving shape like that. These are meant to reduce air frictions, reduce air resistance. And of course, you think about it, when it's curved, lesser friction, lesser resistance, right? Your speed be higher. And then next thing, velocity higher, pressure will be lower. Okay, velocity of the aerofoil increases up here. That means the pressure will decrease. As compared at the bottom, right? No, they didn't decrease. At the bottom, right? Velocity as compared slower. That means the pressure down here higher. Pressure high, pressure low. What happened? They will tend to create a force having upward force. What's this called? This is the one that you're looking for. We call it lift force. Get it? Okay. That's how aerofoil works. Roughly lah. But you notice, same thing I said just now, 4 points. Airflow through the wings steadily. Velocity at the upper region faster than lower region. Pressure at the upper region lower than pressure at the upper region is lesser compared to pressure at the lower region. Difference in pressure creates a lift force. Airplane goes up. Okay. Now next one, they want you to calculate the mass of the aeroplane. How do you calculate mass of aeroplane? Now this man, you complain, hey, I thought you said Bernoulli got no calculations. This is Bernoulli got no formulas. So all the calculations in Bernoulli questions, right? It's old formulas. How do we calculate mass? You see for yourself lah. What are the information provided? They literally give you one thing only, right? They tell you this lift force is 25,000. But normally lah, how do we calculate mass one? What's the first formula come across your mind that has an m inside? You're gonna tell me W equals mg, right? But obviously the problem now is what? They didn't say the mass. They didn't say the weight some more. Right? No. This one is not buoyant force. Okay, listen, people confuse all the time. Airplane, the upward force is called lift. Yes. And right now, I can say lift force equals to the weight of the airplane. Anybody know why we could actually say it this way? Again, it was being told by the questions. Correct, good. Constant height means what? Is the plane going up? Is the plane going down? Okay, what's the force that causes this plane to maintain constant height? No, there's no floating here. I said it the second time already. There's no floating here. Your plane is not floating. Your plane is flying. There's a difference there. Floating is buoyant force. Airplane don't float. Airplane get lifted up. There's difference there. Now, if you tell me this is buoyant force, it's wrong. You're supposed to tell me this is lift. Because why? Now, the lift force is produced by the difference in pressure. But your hot air balloon, do you see any difference in pressure here? Do we let air flow through them? No, right? We just make it bigger. So that's the difference where people confuse all the time. Buoyant force is buoyant force. Lift is lift. Different. You cannot say that same, and you cannot tell me the airplane floating. No airplane floats one. Only buoyant force floating. Here, when it comes to Bernoulli, right? No floating. Your plane is constantly moving one. Floating is like stagnant, not moving, stationary. You know what happened? Your airplane not going to stay in the mid-air without moving, right? I mean, anyhow, they sure move forward, right? So lift is different than buoyant force. But again, right now, we can say the lift and the weight are equal. How come? Because they say constant height. Now, very simple reason, if the lift is greater than weight, what happened? You see the airplane do this, pew, up. Now, if you say the weight is bigger than lift, what happened? You see the plane do this, pew, down. So under what situation they maintain the same height? They don't go up or down. They just keep moving forward. Correct. Lift equals to weight. Yeah. So from here, that's why they give you the lift value, right? 25,000 Newton. 25,000 Newton equals to mg. And of course, now you want m. What do you do? Correct. 25,000 divided by gravity typical. How much? 9.81. And what's the final answer we have? 2548.41998. Okay, we're supposed to leave answer in 3 decimal point, but you round it off to become 42. Unit for mass is kg. Okay, so that's the idea. Okay, since we talk about it, might as well. Normally, right, you know how many force acting on an airplane? Supposedly, right, you know how many force we have acting on an airplane? You're supposed to have 4. Yep, you got lift, you got weight already, man. What are the force we have? Got one thing also. What do you call the force that make the airplane go forward? Correct. Any forward force produced by the engine one, we call them thrust. Not just only airplane, say car, forward force, we can call thrust also. Train, thrust. Forward force produced by engine one, we normally call thrust. One more, of course. What do you have at the backward force here? Typical, what's going back? Air resistance is not wrong, but do we have a better answer? One word. Yes. We normally call them drag. Drag means air frictions, air resistance, same. But no, when we label like that, and yes, they asked, you need to know this. They asked, lift, weight, thrust, drag. Drag is air resistance, correct? Friction cannot right directions, right drag, because friction is more towards like surface one. Like, if I put my hand here and I do this, this is not called frictions. But drag is like air frictions, so it's more accurate to be honest. This one is what you write in marking scheme. Okay? Because a lot of time people will ask me, teacher, can I write this? Instead of saying drag, can I write this? Instead of saying thrust, can I write this? So I'm giving you the marking scheme answer already, and then you want to choose to your own answers. How to score, right? And I'm not even asking you to remember something very difficult. It's a short word. Why do you want to write drag 4 letters? You want to write long answers, right? Okay, can we move on? Next one, based on the following aspect, give suggestions on how airplane in the above can fly higher and faster. First thing first, shape. Look properly first, it's the shape of the body. So what do you think? Body, we can't call them aerofoil. Wings, you call it aerofoil, correct. The body is supposed to be aerodynamic, good. And why is it aerodynamic but not streamlined? Because now you're at the air. Now see, ship, submarine, we call them streamlined. Okay, but aerodynamic, then there you go. Okay, you refer to answer lah. I mean, you can if you doesn't part the copy, it's okay one. You can have full answers anyway. Yeah, you check the full answers lah. If you cannot copy very fast, never mind lah. Take a screenshot. If not, there's full answers for you to refer. I cannot wait too long because I'm waiting for you to copy. Then slower law, we move on. Okay. So if you doesn't part to copy screenshots, if not, full answers. Check, download yourself. Material for the body. I know you study chemistry, very good, okay? You tell me duralumin, correct. But again, if you could, right, every time they ask material, especially this kind of writing, you write yourself one. Okay, if let's say essay that you choose, they put there copper, duralumin, aluminium, titanium, whatever name, right? Then you say, I want these, because that one best, among the 4 choices you have. That one, okay, you write the name. But then these kind of answers that you write yourself, right, it's always best to describe the property. Okay, material, always best to describe the property. Unless it's like the choosing one. Essay you choose, they give what you copy, that one. Correct. But you write yourself, right? Property. So what is the most important property, characteristics of the body you must have? Okay, at the first place, why do you tell me you use that whatever duralumin? It's an alloy, right? Very light, yes. Then say very light. So material should have low density. Why low density? Lightweight. Okay, lift force, able to push the airplane to a greater height. Answer the requirement by the questions. The question wants you to go faster, so we do aerodynamic. The question wants you to go higher, so we do low density. Understand? Next one, surface area of the wings. Wings is the reason that you have lift force, because the shape of the wings is aerofoil. So what's the surface area of the wing has to be? Big, small. Of course, 3 marks, bigger area. Why? Why bigger area is better? Okay, more lift force is correct actually. Okay, produce a greater lift force. But do you know why actually your wing bigger then you got more lift force? Okay, first thing, can you tell me what's the reason we have this lift? Aerofoil, yes. How come you got this lift but not going down? Because the pressure here big, up here down, right? What's the reason that you have a force? The difference in pressure created the force, yes? Yes? Now, difference in pressure created this. Simple calculation here, guys. If this one don't copy first, if pressure is F over A, can you rearrange this? And you tell me F equals to what? Pressure is F over A, so F equals what? Pressure multiplied by area. So, if your area is bigger, what happened to this? Bigger law. So why bigger area actually give you more force? That's the main reason. Okay. Diagram 1 shows the cross sections of a spoiler. You know what this is, right? Yeah. Which installed at the back of the racing car. Name the shape of the spoiler. What shape is this? You got no idea. Aerofoil is like this one. Right? Does it look like an aerofoil to you? Okay, but then you see, if I do this, now, does it match? It looks exactly the same, right? So what do I do? Correct. you reversed it, you flip it. So this one, teacher, very particular one. You tell me aerofoil is wrong. Yes, inverted aerofoil. Reverse aerofoil also can. But you cannot write inverse aerofoil. I don't know, you decided to combine the word inverted and reverse, both. Inverse. Yes, mathematics inverse is, that one is what, your function, then only got inverse what. So either you write the word inverted, if not write reversed. But please don't write inversed. Next one, when the racing car is moving fast. Okay, by the way, how this thing works? Same thing, right? Air flow through, air flow through. Could you tell me where we get high speed now? Where do you get high speed? Up or down? Up or down? Speed higher? Always the curved part that has lesser air friction. So down here fast long, correct? And then if your speed fast means what? Pressure low. If your speed slow means what? Pressure high. Pressure high pushed to pressure low. Right now, what force we have? Correct. That's why, okay, you know why you want the down force or not? Because you press the car down so that the car won't flip. They told you, when the car racing, moving very fast, remain stable, due to difference in pressure, create a down force. Explain how the difference in pressure produce. Okay, now you see different situations, right? But what did I say? Every time Bernoulli principle, how do we answer this? Step one, correct. No. You tell me the keyword first. What's the first thing? What's the first thing we say? When the racing car move forward with high speed, air flow through the spoiler steadily. Always start from this. Then next thing, what do we say? After talk about the steady already, what do you say? No, you listen first. You answer my question first. Second is compare velocity, correct? The velocity at the upper sides of the spoiler is, okay, if you say upper side, faster or slower? Upper side lower than the velocity of air. Velocity of air, at the upper side of the spoiler is lower than the velocity of air at the bottom side. Okay, next thing, what happened when your velocity changes? The pressure of air at the upper side of the spoiler will be greater than the bottom side. Finally, the difference in pressure will create a down force. You can say downward force, you can say down force, actually same one. You can say down force also. That pushes the car downward and remain stable. Nah. So do you need more example? Or Bernoulli's answer like that, what? I mean, of course you change a bit depending on situations but then you see, you get what I mean, right? Why do I say understand the topic very important? Because it applies every time. There's a format there one. Airflow steady, right or not? Talk about the airflow steady, then velocity upper, lower than velocity bottom, compare the speed, right? Pressure upper, greater than bottom. Difference in pressure create force. Depends on directions now. If they push up, then you say lift force. If they go down, then it's down force. There you go. So 4 marks. 1, 2, 3, and 4. We good? Okay, you write down the answer first. I need to go toilet. And I'll come back real fast. Let me know when you're done. And then you can try question number 3 first. Yeah. But once you're done copy, right, you send me this one. I want a race car. I'll come back. Okay, second questions. Sorry, third questions. Area of a lower surface of this spoiler is 0.35 meter square. Pressure at the upper surface 2005. Lower surface 1000 Pascal. Calculate the downward force acting on the spoiler. How? What did I say just now? What's the reason that you have this downward force? Nah, up here. Difference in pressure, ma. Okay. Of course, you say, hey, I thought Bernoulli got no formulas. Yes, we are not having formulas. We are using basic one only. You see what is provided? They give you the area, okay? And then they give you pressure. And then they want you to find force. What kind of formula come across your mind? One only what? Pressure equals to, don't copy first, pressure equals force over area. So if I want force, what should I do? Divide, bring over. That means you get force equals to pressure multiply area. Good. But then we got two pressure. Which one? Again, read the answer you wrote. Difference in pressure. So, supposingly, if you want the proper answers, the downward force are created by difference in pressure, then you multiply by area. Some book they write like that. Yep. So, not the top one, not the bottom one, but the difference between them. So, you're supposed to take two of them. Sometimes they tell you straight away the difference in pressure, then you just copy long. But this one, they give you both up and down, right? Remember, minus them. And then only multiply by the area. Okay, what do we get? 525 Newton, correct. Okay. Found it? Anyone having problems? This one could be quite easy, right? Can I move on some more? Alright, then we can go for Pascal. Okay. Next. Question 5. Page 19. Question 5, page 19. Question 5, page 19. Diagram 11.1 shows the hydraulic jack applied to force. Applied to the pistons, not power. Sorry. Okay. F1. Okay. Now, here's the keyword. So how do I know am I doing a Pascal principle? See, Archimedes is when you see something inside water, inside air. And then Bernoulli is when you see air flowing, water flowing, right? Pascal, look for this word. The moment they say hydraulic, confirm Pascal. Okay? Pascal principle. What is meant by Pascal principle? Definition, basically what we try to say is, what is it? Okay, what's the essential thing? What's the two words that you can use to describe the whole Pascal principle? Pressure will be the same, right? So Pascal principle states that the pressure, Pascal principle states that the pressure exerted on an enclosed systems, enclosed fluid, whatever, is transmitted equally in all directions throughout the entire fluid. The sentence slightly different is fine one. I tell you what, this whole definitions, there's 3 key points you must put inside. How you write, up to you. But most importantly says what? You must mention this enclosed systems. Second, pressure how? Transmitted equally, yes. And then a lot of time people forget the third point. It will be transmitted equally in every directions, all directions. So 3 keywords. Enclosed system, pressure equal, all directions. Enclosed system means tightly sealed up, okay, like this. Whatever inside don't come out, whatever outside don't go in, that's called enclosed. It's like, let's say you have a water bottle, you close the cap, your bottle is enclosed systems. You get it? Closed. Cannot understand enclosed? Look at this word, closed. Simple. Okay. Speaking of Pascal, do you recall formulas? Pascal got formulas, what? There's no formulas. What is it? Simple, right? Yeah, they tell you pressure same. Okay, how do you calculate pressure? Correct. How do you calculate pressure? Force over A. So, pressure same means what? Pressure is F over area. Pressure is F over area. So, if your pressure same means force over area equal force over area, F1, A1, F2, A2. You get it? There you go. F1, A1, F2, A2. Okay? But one thing, guys, your pressure same, right? Does that mean the force must be same? Because now got F1, F2. Can I say F1, F2 same also? Of course, won't. Why? Because your area different, what? Then here, area is 0.5, area is 8. Not same, right? Okay, here, guys. If I say area is 1, simple maths first. Force is 1, area 1. And then A2 here, I put 10. Could you tell me how much for F2? 10 also, right? 1 over 1 is 10 over 1, 10 over 10, right? So what do you notice? Your area smaller, your force smaller. Your area bigger, your force bigger. So always is like that one. Whenever you got two pistons, what's the function for hydraulic systems? Whatever hydraulic, they use to amplify your force. Make your force go bigger one. Understand? Now over here, got two pistons. They got all kind of different names one. Sometimes we call it input and output pistons. Input means where you press, and we always press a small one. Because the small area, you have to apply for small force only. And then the big area will have big force. So if you're going to press here, you know what's the problem or not? Your bigger force come over here, become small one. Then why do you want to do this? You want more force, what? Lesser force, you just reduce yourself. You want to amplify it, right or not? So for this hydraulic systems idea, number one, sometimes we call them input, output pistons. Sometimes we call them by size. We call this like small pistons, and then this one the big pistons. And sometimes we call them by what? Sometimes they also have a very funny names. Is that sometimes, right, you see them also. I'm not joking one. This one is for real. The official name one. Sometimes they also call them master pistons for the input. And guessed, what is it for output? Master piston is input, my output is what? Opposite of master is what? Yes, they call it slave. Yes, last time people don't care about politically correct this kind of thing one. So master pistons and then slave pistons. Okay? Now, for the master pistons, do you want the area here big or small? This is when you need to understand, right, function of them. Because sometimes people look at the answers, they cannot understand. They will ask me like, hey, how come the area small, then the pressure big, but then the area big, the force become big one? Why is it not same, right? Okay, then this is why you need to understand the difference between input and output pistons, between master and output slave pistons. Okay, now what's the function for master and slave pistons? Here's the thing. Number one, we got two job, right? One guy is to produce pressure, one guy is to produce force. Okay, first thing first, which pistons is the piston that generate force? Like, we used to produce larger force one. Simple one. The name tells you the answers, right? Think about it last time. Who's the one that, no. Who's the one that carry the heavy stuff? Who's the one that, you put your heavy load there, you carry all the big rocks, big tree trunks, whatever, the master or slave? Of course, the slave, right? Because you need to carry heavy stuff, right? So, slave, right? The slave pistons, the function is to produce force. Okay? Slave pistons is to produce force. Master need to produce force or not? They don't have to. What they do? They just beat the slave, right? So what does master do? Master basically just produce pressure. That's the point. Master generate pressure, and then what happens? The pressure will send over to the slave pistons, and then slave will produce force. Get it? So simple, same formulas. Pressure equals to force over area. So if you produce pressure, obviously the more pressure better. So what do? The area should be bigger or smaller? If I want more pressure, area smaller, yes? That's the point. The force is constant. You reduce the area, they increase the pressure. On the other side, right, same formulas anyway, we also do pressure equals to force over area. But then for slave, what happened? Your pressure is constant. That's why area go up, force increase. So this is the one thing that I get asked a lot. Students ask me, hey, why when I change area for master, the pressure will change? But when it comes to slave, right, when I change area, the force will change. I mean, shouldn't area bigger, pressure smaller? Here's the answers. The pressure will be transmitted equally. So once the input here generate pressure, right, they will send over. Slave pistons got no say one. Whatever pressure delivered by the master pistons, they take it. So this is why for output pistons, for slave pistons, your pressure is fixed. It's constant. Why? Simple what? This one here, pressure sent over. So that's why pressure constants and then increase area, more force. This one here, your force is constant because force is generated by us. Human, we have limited force one. That's the best we could do, right? Maximum constant. Okay? So whole process, what do you do? Now this is a hydraulic jack. Do you know what's a hydraulic jack anyway? What do we use it for? Hydraulic jack, we use it in those workshop, car workshop. Have you seen before? Red color one. Like a trolley kind of thing, and then you put it under the car. And then they will pull the lever, pull, and then the car will slowly come up all the way. Hydraulic jack. So this thing, right? Where do we put the car? We put here. And then what do? We apply force here, and then the car will slowly rise up. Okay? So here, they ask you to explain how the hydraulic jack can be used to lift up a car when F1 is applied on the input pistons. Right? In your explanation, state how the F2 acted on the output pistons is greater, and then can be used to lift a heavy car. Okay, I want to say this one. This one is considered one of the point. I forgot to remove these answers. This is 1 point already. When F1 is applied on the input pistons, when we apply force on input piston, what happens? We generate pressure. Okay? And then the pressure is big. Why? Because the area, how? Due to its smaller cross sectional area. Okay? Smaller cross sectional area. You help me to write this in. Smaller. What happened? Due to a smaller cross-sectional area. No space. Shoot. Okay. First thing, apply pressure first. Second thing, what happened? You apply pressure already, then the pressure how? The pressure exerted, or you can say the pressure produced by the input pistons will be transmitted equally in all directions throughout the hydraulic systems to the output pistons. Okay, second point, you tell them your pressure will transmit equally all the way to the other side. Meaning, step 1, apply force here. Small area gives you big pressure. Pressure big, send over to the large pistons, to the output pistons. And then next thing, what happened? Again, remember functions? The output pistons will create a force and lift up the car. But not done yet, of course. Why? You never talk about the property of the output pistons. What? Must be big or small? Then the point you say what? The force produced by the output pistons is greater than the force produced by input pistons due to its larger cross-sectional area. Okay, so for marks, the top line is considered 1 mark. This one I forgot to remove the answers. So it's 1, and then 2, and then 3, and then 4. All good, everybody? Write down answers. Let me know when you're done. When's your exam? When is your exam? I know some of you done. I mean, if you're done with exam, you probably won't be. You won't be in my class now. You're probably done already. 16th of April means next week. 24th of April, tomorrow. Oh, what school tomorrow? 15 minutes this week. Oh, DJ. 22. 22 is next week. No? Next week basically. If you consider Sunday is the first day of the day, first day of the week. So most of you next week. There will be replay for this. There will be replay. But I cannot promise what time because the problem is it's not okay. I upload very fast one, but then the thing is sometimes they have to check the video, like whether you upload to Google, you upload to YouTube, right? They will check the video, so it's especially in my video it's like 2 hours plus. Takes longer time to process. So sometimes take hours, but once it's done, I'll post soon. Paper 2 tomorrow, paper 1 next Tuesday. Yeah. So if you say tomorrow, I don't think we can manage to make it in time. But I think by tomorrow, I will have tomorrow I can definitely be able to post it already. So if you say tomorrow is your paper, then that one a bit difficult. Okay, come next. Wait, sorry. Given the force applied on the input pistons is 25 Newton, and then they want the force produced by the output pistons. Well, obviously, what do? Formula for Pascal principle. F1 over A1 equals to F2 over A2. Typical, huh? Substitute inside, we get answers. F1 would be 25 Newton. Okay, and then A1 is how much? Let's see. Here F1, here A1, 0.5, and then A2 8 meters square. So this one we put 0.5 equals to area 2 is 8. F2 is looking for. Okay, F2 how much? F2. 25 divided by 0.5 multiply 8. What do you get? Okay, did you get 400 Newton? There you go. Okay, got one more question I can ask you. This one, the question never asked, but I tell you what, Pascal principle got another, not exactly formula thing, but they will ask one. Okay, besides calculating force, you know what can they ask or not? They will tell you this. I mean, let's say my question like this. If I pushed here, of course, the piston going to move downwards, right? So let's say if the piston here moved down by 5 cm, how many cm this side will come up? Here's my questions. If I push the input down by 5 cm, what is the height increases by the output pistons? Well, if you think about it, this is enclosed systems, right? So when you push it down here, the liquid go down, right? Of course, they will come up the other side. But then here's the thing. Can I say this one also 5? 5 down and then 5 up. If like that, then not going to ask you calculate already. What? Okay, then why not? So the question is, why not? 5 go down, the other come up. Why not? Because your area different, correct. And second thing is, now your mindset is correct one, okay? If I push down here, the liquid go down, surely comes up this side. Okay, this side go down, the other side sure come on. Confirm that one, right now. But the problem is, we don't use height. We don't use this cm to measure amount of liquid right now. What's the unit we used? What's the term we used to measure amount of liquid? That is not correct. Okay, like you know your drinks, your canned drinks, your bottled drinks, how they tell how many water inside, how many liquid inside? There will be a label that says EC Padu, right? That one BM. So if you translate EC Padu in English is what? Volume, correct. We don't do ml because what's another way to measure unit for volume beside ml? Meter cube, correct. Like you're not gonna go to some mamak store and then tell him I want 5 cm Milo ice, I want 7 cm Milo ice. Doesn't make sense, right? So you're supposed to say I want 500 ml, I want 500. Of course, you say nobody says 500 cm cube also, right? I get it, but science, right? So the logic is same one. Okay, first That's why I need to understand the meaning of the word enclosed. Enclosed systems, it means the liquid won't. Enclosed systems, it means the liquid is not gonna change. Constant one. So how much goes down will surely equals to the same amount that goes up. Okay? How much goes down will surely equals to the same amount that goes up. But you cannot tell me it's height because we don't measure liquid in terms of height. Instead, what we do, we say volume. Volume goes down equals to volume goes up. Okay? Then, how do you calculate volume? We said just now, right? No, this is not maths lah. You say, oh, do I need to calculate like cylinder? Piston is cylinder shape, so I need to do like what, pi r square h, that kind of thing. No need. Why? Okay, simple idea. You know what's pi r square? Just pi r square alone. Yeah, I told you just now, right? Whatever shape formulas, what do? Area multiplied by height equals to volume. Area multiplied by height equals to volume. So that's why, right, for this one, you just need to say volume equals to area times height. And then this one also area times height. The volume that goes down, it will equals to the volume that goes up. You understand? Substitute accordingly, we get answers. Area that goes down here, what do we have? 0.5. And then the one that goes up is 8 meters square. So this one is 0.5. Multiply the h is how much? I said 5, right, just now? There, I said 5 here, right? And then the other side, the area is 8. And then multiply by h, the height that goes up. So what's the height that's supposed to go up on the other side, on the big pistons? 0.5 multiplied by 5 divided by 8. How much do we get? 0.3, 0.3125 cm. Yes, very small one, the amount. Because your area very big. That's why they only got a little bit, then they generate the same amount of volume already. Okay, so this one, be careful also. Sometimes they come up. So Pascal, actually, if you want to consider, got 2 types of calculation questions. One is for this, the pressure, the F1 over A1 thing, and then one is for this, the volume up and down thing. Good. Move on. Alright, next. Diagram 11.2 shows a hydraulic chair used by dentists to treat patients. Now you're supposed to design this chair. You need to build a hydraulic chair that can withstand big loads and safe to use. Okay? Don't have to convert same unit. We convert already. No, we convert already. Oh, no. Oh, you mean the cm? Okay. You know why or not? Because here, this one is meter. Okay? This one cm. But then, what's the unit for 8? It's meter square. So when you bring over, it cancels off, isn't it? So this is why I put cm, because the 5 is cm. They cancel off. Doesn't matter. Okay? Alright, here. Design. You're supposed to mention the characteristics of fluid used, the material for making the chair, and then the pedals, and then also additional characteristics. Okay, first, do you know hydraulic system, how it works actually? This thing. Okay, of course, you're going to step on the pedal, right? Okay, I tell you what, actually hydraulic jack and this thing very similar one. So first, right, you have something called the valve. Do you know what's a valve? Like your blood vessels inside the valve. Yes, what was the function for the blood vessels valve? Prevent the blood from going back, right? Backflow, right? Same thing here. Having valve, right, it actually prevents the liquid flowing back. Now, normally in your hydraulic systems, this kind of hydraulic jack, hydraulic chair, whatever, right, they normally got 2 valves. 2. Why? Now look. First, we put a valve here. Okay? And then you see the directions. If I put the valve this way, it means that they only allow liquid to go this way. When liquid come here, it close up and block. Okay? Now another valve, right, we will put it here. And the direction is like this one. Meaning the liquid here can come in, but you cannot go back inside from here. So what happened when you press on the pedal? Okay, step 1. When I press on the pedal, of course you're going to squeeze the liquid, right? You squeeze the liquid, squeeze. Now can I go in? Block, right? Valve ma. That means you can only go here and then go to this part. They pump up the output pistons. That's why your chair start rising. So when you keep pressing, so they pump. Okay, when you press the pedal, they will actually force the liquid in here. Okay, step 1, press, go through the valve. From here, go inside, go through, and then beep comes up. Right. Second, after you're done already, what happened? You need to come down, right? If not, what, you leave the patient up there and say, hey, you jump down yourself, right? So this is why you will notice you got one thing called the release valve. Okay, the name kind of tells you the function of it, right? You know what's a release? What does a release valve do? It released. Released, right? Okay, this thing can open it. I mean, like you manually turn it. Use your hand to turn it. So when you open the release valve, right, what it does, because right now your liquid cannot flow back this way, it's blocking, right? So when you open the release valve, right, the liquid here, they will actually come down because you're sitting on it, and then they flow in back here. You see, go in through here, and then, right, next time you want to use it, what happened? The liquid here will come in, and then you keep pumping and repeat. So the whole cycle like this, look, press the pedal, pump liquid in, and then this one will flow in, refill, and then you pump and pump and pump. They go up, go up, go up. Next thing, you open the release valve, they come back down, here blocking, that's why they go in here, go in here, go in here, flow back to this point, this one slowly come down. So next time you want to do the same thing, close the release valve again. Okay? Alright, so design. First thing, what is the thing that we talk about? Of course, most importantly, hydraulic system is what? Must be the liquid that you use, right? Must be the fluid that you use, right? Now, you can say what kind of liquid here, because normally for hydraulic fluid, we use the same liquid. What kind of thing we use? Okay, first, right, it says characteristics of fluid. Again, fluids means liquid or gas, right? But is it best to use air or liquid? I'm sorry, gas or liquid? It's always better to choose liquid or better to choose gas? Liquid, yes. Why? Because liquid incompressible. Okay? But there are so many liquids. What is the best liquid that we normally use for hydraulic systems? What kind of liquid we put inside? Typical, the common one. No, water cannot. Beside water, we use oil. Correct. So you could say, because this one is quite specific, right? So the hydraulic fluid, or say liquid, okay, should use oil. Why do you use oil? How come use oil? There's many reasons. You write one enough. Okay, I list down for you because sometimes they can ask you in other questions. What's the advantage of using oil versus like water versus whatever? Okay, listen if you're going to tell me incompressible, but you have to be very careful. Now here, you can write oil incompressible because this one design. Okay, this one design. You write yourself one, no problems. But then those decide essay, the choosing one, right? Then you have to be careful. If the questions let you choose between water and oil, then incompressible cannot be answered. Why? Because liquid and oil, right, both are liquid. I'm sorry, water and oil, both are liquid. No good. Now, if let's say the questions let you choose between oil and air, then you tell me air incompressible, you tell me oil incompressible, you are correct. So here, no problem. But the choosing essay, the decide essay, you want to be careful. That one don't simply use the word incompressible. But that's why normally incompressible, right? Never in my first choice one. Unless I need to write more, and I write more. If not, what is another one? The most typical reason, why do we use oil rather than water? Actually, the reason very simple. Most of your hydraulic pistons, right, they made of metal. Most of the hydraulic pistons, right, they made of metal. So why do we use oil? Advantage for oil does not cause rusting. Resulting rusting. Okay. No corrosion can also but normally we just say does not cause rusting that easy. Then you can say the boiling point thing also. In fact, you can write more underneath, Yeah, you can repeat another point as characteristics one. Then you can talk about the high boiling point thing. Okay, or you can say, if you don't want to say high boiling point, what's another better word to use? Low rate of evaporations, which is also good. Yep, the meaning of low rate means it does not vaporize easily. Any other answers beside this? Got some more? Oil got a lot of advantage one. Why do you choose oil rather than water? Oil, low density. Why do you choose oil rather than water? Or you got one more thing is that you can also say it's high viscosity. I give you 4 reasons. Oh, okay, now guys, listen. Don't put all 4 inside. Every time, right, when you're doing when you're answering essay, right, the reason, choose one. I give you this is all the advantage of oil. So let's say in structural question, they want 3 advantage, you answer. But essay, right, write one. So your answer should be oil, and then write this, enough. Okay, viscosity means the stickiness. High viscosity means what? Like, okay, liquid when you pour, it flows very slowly one. That one called high viscosity. Like, tomato sauce, honey, that kind of thing. And why do you want high viscosity, right? Okay, this one I explain to you. Because it does not leak easily. No need to write this. I just want you to understand. Viscosity high, they don't leak so easily. If you put water, right, they will leak out from the small gaps very easily. But of course, we got many other answers, right? Choose the one that you normally use. This one rusting most important. Cheap is not exactly correct because actually water cheaper. So cheap is no good. Alright, material to make the chair. The chair need to support a heavier load. So the material of the chair is supposed to be, yes, stronger, correct. Stronger, good. Why stronger? Does not break easily, can, right? Or you can say able to withstand heavier load, or able to withstand higher pressure, heavier load better. Does not break easily. 2 reasons, choose one to write. What else can we say? Pedals. The one you pressed means you're gonna steps on it, and then you're gonna apply force one. Material of the pedal should be also stronger. Can actually you can write same point one, no problems. But if you want to write stronger for pedals, you can write other answers also. What? High density, no lah. You want low density, what is it? Lightweight, right? High density doesn't sound like a good choice though. The chair made of steel can also, right? Okay, should be stronger. Okay. Why? Able to withstand. Does not break when force is exerted on the pedal. Now some people always ask one, can I repeat answers? I can repeat answer this way or me? Right? I can repeat answer this way, right? Well, in SPM you can repeat answer twice. Like, because some of you say, hey, here say does not break easily already, then here you say does not break again. You can repeat twice. The third time, okay? Now, if you don't want to repeat, very easy, is there any other point can we say about the chair? Okay, let's say this one you don't feel comfortable saying both should be stronger. Do we have other answers saying the chair besides stronger? What other answer can we say? You can also say the material for chair, how? Lower density. Low density also a very good point. Why is that so? Lightweight. Okay, easy to bring around and everything. But then lightweight will do actually. Then you don't have to repeat already. But this one you write one answer only. Yeah, one answer. Please don't write because you got a lot of other answers to write. Okay, what else can you say? The hydraulic systems. Okay, one thing that people tend to ignore is here. You know what's this? The transmission pipe. Normally made of what material? That pipe. Usually again, made of steel, stainless steel, right? the pipe is to withstand high pressure, because when you apply pressure, right, they're gonna apply pressure everywhere. Remember, pressure transmitted all directions. So the thing is, your pressure is actually not like this, come over. No, they press everywhere one. Meaning on the wall, you get pressure pushing also. Understood? So that's why here, supposingly you can also say the transmission pipe should made of steel also can. If you don't want to say steel, you can say stronger material also. Again, that's why I don't want to repeat so many times stronger lah. Looks like, this one also stronger, that one also stronger. So that's why I give you the material for the chair, low density. So you can write stronger for the pedals. Harder for pedal also can, but usually be stronger. Durable, don't say. Durable, no good. Okay? But then your reasoning, totally different reason. Able to withstand higher pressure exerted. Or you can say acting on the pipe and does not burst easily. What other additional characteristics can we have? Okay, one thing. Remember, I talked about the release valve or not? They do put it here lah. But actually, whenever we talk about all these hydraulic systems, right, you can put one more. Is that should you have a release valve or not? What do you think? It's like a free marks to you one. So every time you say this hydraulic jack, hydraulic whatever, then you can say equip with release valve. What is the function for this release valve thing? What's the function for this release valve? To release pressure, yes. Then what? Yes, to allow the hydraulic fluid to flow back and lower the chair to original positions. It's like a reset valve lah, basically. Okay. So this is the thing that we need to mention about Pascal principle. I put more is because in exam you don't know exactly what they ask ma. That's why I give you all kind of different property, different answers. So imagine they don't ask for hydraulic chair. They ask for hydraulic brake systems, hydraulic jack. You can also use them quite often. This is definitely usable one. This is definitely usable because the transmission pipe confirm have one. Whatever hydraulic systems, you sure need the pipes one. So this is like a universal answer. This one like universal answer. This one like universal answer. So this three is applicable for all kind of questions. Release valve depends. Sometimes they, let's say for hydraulic brake, then there's no release valve. You press, they press. You let go, they don't let go. Because brake, if they wait for you to press the release valve very slow. So that one very responsive. Car brake, you press, pressure send over. You let go, pressure come back. Okay, are you done for this? I want to go through one more question real quick. The Cartesian driver, what's wrong with why like initially you don't put water inside? Just leave it blank. Just imagine a bottle with no water inside. The thing, okay, Cartesian diver itself has weight one. So when you put it inside water, it will go down one. Just that inside will have air columns. So the air basically inside need to if you don't apply extra pressure, they won't escape one. Idea very similar to one thing also. Like your straw you put inside water, the water don't go in fully one, right? There will be some little bit kind of air stuck there, unless you push, you die force water in again, then you squeeze the air out, right? Same thing one. So it could be empty, no problems. Maybe got water go inside a bit lah, but initially it's like more empty part. Inside got more air, and then you squeeze, go inside. Are we done for this? I want to go through the spring questions real quick. I'm not doing the whole thing. I just want to talk about the essay. You done for this already? If not, you screenshots. Alright, now everybody page 15. Last questions I want to do about this one. Here, it's a mattress. But, okay, when we say spring, also they also like to come out essay on. Because mattress, I mean spring, they can put inside mattress, sofa, all kind of thing, right? Inside got spring on. So now you want to choose the best mattress, and then the mattress requirement is what? You need to be able to withstand heavier load and then only compress on the part that is being pressed. Okay, why do I need to talk about this? Because the first one that people always ask me, what kind of spring do we use? This one a bit off syllabus now, to be honest. You don't learn this in your textbook one. Okay, what kind of spring do we use? You got two choice. You got inner spring, you got pocket spring. Well, if you look at the drawings, what is the difference that you could see? Look at the drawings of the springs for this one and this one. Could you see the difference there? Well, inner spring, do you realize they are all connected together? Right? And then for the pocket spring, it's like one isolated spring, one by one, individual one, right? So which one is better? Yes, pocket spring better because, I mean, that's what they want. You want to make sure the spring only compress at the part that's being pressed. You know what happened for inner spring or not? Let's say if you slip here, alright, your weight acting downwards here, right? Actually, all the spring get compressed one. Of course, this part will compress more, but your back will be like this. They go in, and then this one. So let's say if your mattress are having 2%, the person next to you, okay, could feel that back going down also. And then, sleeping, you sometimes move around, right? Your movement will cause this thing go down a bit more, and then this person will move together with you as well. So people with light sleeper has this problem. They will wake up. But this one is better, you know why? They are isolated. They are one by one. So if I sleep here, what happened? These two mattresses will compress, and this one will stay up there, stay up there, stay up there. Then the person will not feel anything. Recently, you will always see when they promote their mattress. I'm not sure you've seen before or not, because you're probably not at the age group also. There will be advertisement where they want to promote their mattress very stable. They put a glass of water there, and then they jump next to it. The water will stay there without toppling. That's because inside they will separate them. They don't use inner spring anymore. Okay. Next one, diameter of the spring wire. Okay, regarding this one, when of course we have to go back to what we learned in textbook and physics, right? So here's one thing. Every time you do with all this essay answer about physics, right? I tell you what, when they ask about spring, it's always the same thing one. Okay, it's the factor that affect the spring constants. Remember spring constants, right? As in like stiffness of the spring. So before you answer, before you choose anything, right, you decide first. Do you want a hard spring or do you want a soft spring? Okay, so spring constant higher means the spring is harder. Okay, spring constant lower, it means the spring is softer. And do you recall what is the property that affects spring constants? Then why is it the assay? Okay, why is it assay? Because always, right, we got four factors here, am I right? Number one is the length. Number two is the wire diameter. Wire diameter. Okay. And then third point, you have the coil diameter. Later I explain to you. People always ask me one. And then finally, you have the material. So 4 factors, that's why it makes it a perfect point to ask you essay. Okay. Now, first thing you decide. Now this mattress, do you want a hard spring or soft spring? The requirement of the question is you need a mattress that is able to withstand a heavier load. So what do you think? Yes, of course you want a hard spring. Harder spring only can support. Because if it's soft, if you are very heavy, what happens? You slip on it, they will sink all the way in, right? So spring constant higher. Okay. Now, one by one, length, what do you want? If you want a harder spring, the length of the spring is supposed to be shorter. Okay. Now, people always ask me about this too. Actually, what's the meaning of wire diameter and coil diameter? Wire diameter means the spring. Now, spring is made of the metal wire, right? So wire diameter means the thickness of the wire. As in like this. Imagine I got one spring like this. And then if I want a thicker wire of diameter like this. Now, if you look at the size, it's pretty much same one. But what's the difference between them? This one obviously you can see, right? The wire is like thicker. That is the meaning of thicker diameter. Wire diameter. Okay? Now, if you want a hard spring, what do you want? Do you want a thinner one or you want a thicker one? Of course, we want a thicker one. Now, spring, very simple one. If the material or anything you used to make the spring originally is hard, then the spring come out will be hard. You get me, right? So think about it. If you got 2 wire, just a straight wire, thicker wire is harder, right? Then the spring they made out of will also be harder. Get it? Next one, coil diameter means what? As in like how big the spring is. Coil diameter like this. Spring 1 and then spring 2. You notice I use the same thickness now, right? But you see the difference or not? This one has a bigger circle. This one has a smaller circle. That's the meaning of coil diameter. Okay? Now, if you want a hard spring, which one do we choose? The big one? Sorry. The big one or the small one? Actually, you want to choose small one. Why? Because you can see this way, when they are smaller circle, right? It's like all your friends united together, all together supporting one point. So this one is like all spread out one. So not good lah. Huh? So this is why, right, for the coil diameter, smaller diameter. And finally, what about material? You can say exactly what material lah, but then normally I say my right when we say material, what? Yep, if you as I say my right, if the material is harder, the spring comes out harder. So this is the thing. Now, if you want a low spring constant spring, you want a soft spring, right? Everything terbalik. Make the length longer, diameter wire smaller, coil diameter bigger, and then softer material. But right now, since we're looking for a hard spring, now got answer already, right? Diameter of the spring wire, choose what? Small or big? Correct, choose big. Diameter of the coil, choose small. And then material for the spring, we choose steel. So finally, what's the answer we have? L. All good? Can decide now? So spring question, to be honest, not that crazy hard. When you remember the properties, shouldn't be a big issues. Always ask yourself first, I want a hard spring or soft spring? And I give you a simple hint. 80% of the time, right, your spring also you choose hard one. Like mattress, we choose hard spring. Sofa, we choose hard spring. You know the suspension for motorcycle? Also hard spring. So most of the time we choose hard one. When to choose soft? Unless they mention so. Mechanical pencil, kind of. They will tell one. They will tell. Then this one, they kind of remind you, I want to withstand heavier load. Then I want a hard spring. Okay? The answer explanation, you refer to full answers. All good. Anything to ask before I move on? Okay. Alright, so for those who are having exam tomorrow, all the best for exam. Please study very hard. Midterm, to be honest, lesson chapter, right? Try law. Okay? So study very hard, finish the book, and then you should be prepared. But finish everything. Okay, if not, this is all we need to go through today, and I will see you when I see you. Bye-bye.